Welcome back to Lines and Planes. Before we do some applications, let's just review the two major things we learned last time. Parametric equations for a line through a given point with a given direction vector. Three equations: x equals x naught plus at, y equals y naught plus bt, and z equals z naught plus ct. Okay, and the general equation of a plane through a given point with a normal vector is the use me everyday formula. Big A times x minus x naught plus big B times y minus y naught plus big C times z minus z naught equals 0. That's the use me every day. And typically after we write that down, then we go ahead and we simplify to the form ax plus by plus cz equals d. Okay, so let's jump in. Find the general form of the equation of a plane through 3 points, P, Q, and R. So here's P, here's Q, here's R. We want a plane that goes through those 3 points. Well, we have a point on the plane. We can use P, Q, or R, but we're going to need a normal vector. And the way we'll do that is we'll use the fact that PQ and PR both lie in the plane that we're talking about. And so PQ cross PR will be normal to that plane. And so that will be our normal vector. Now I've gone ahead and computed PQ and PR. For PQ, you take the Q's minus the P's. For PR, take the R's minus the P's. And you should pause the video and double check that you could do that on your own. Okay, and so now we're ready to cross. N is PQ cross PR, and that's I, J, K, 1, negative 1, 3, negative 1, negative 3, 2. You should pause the video and see if you can do that cross on your own. Okay, hopefully you got 7, negative 5, negative 4, because that is the cross product. That's our capital A, capital B, capital C. All right, now we can use the use me everyday formula with either P, Q, or R as our base point. It doesn't matter. I'm going to use P as my x naught, y naught, z naught, and recall P is 1, 1, negative 1. So here's the use me every day. 7 times x minus 1 minus 5 times y minus 1 minus 4 times z plus 1 equals 0. So that's 7x minus 7 minus 5y plus 5 minus 4z minus 4 is 0. And if we clean that up, we get 7x minus 5y minus 4z equals 6. Okay, let's do another one. Parameterize the line of intersection of two planes. So recall, for a line, we're going to need two things. We're going to need a point on the line, and we're going to need a direction vector v. All right, we'll do the direction vector first. So I'll say this is 1 and this is 2. So for 1, I'm going to let v equal n1 cross n2. And here's what n1 and n2 are. So if we go back up here to the solution start, I wrote down the respective normals of each plane. And the way I did that is I used the Cool theorem, which says if you pluck off the coefficients of x, y, and z in the standard equation of a plane, you're going to get the normal to the plane. So I have n1 and n2, and I cross those, and that will give me a vector that lies actually in both planes. So this is going to be I, J, K, and you might want to think about why that is. 1, negative 2, 4, 1, 1, negative 2. And again, you might want to pause and see if you can do that crossing. All right, I got 0, 6, 3. So that's going to be my little a, little b, little c in the parametric equations of a line. So for 2, I need a point on the line, and the point has to lie in both planes. So what I'm going to do is set z equal to 0 in both plane equations. Nothing special about z. I could have set x equal to 0 or y equals 0. But if I set z equal to 0, here's what I get. The two equations are x minus 2y equals 2 and x plus y equals 5. Now I'm down to two equations, two unknowns, and I can solve that linear system. I'll subtract the second equation from the first to get negative 3y is negative 3. So now I know y is equal to 1. Now I go back to either one of those equations, plug in y equals 1, and I see that x is 4. So my x naught, y naught, z naught is 4, 1, 0, because we set z equal to 0 in the beginning. So I'm ready for my parametric equations. X equals x naught plus at. So that's just 4 because a is 0. Y is y naught plus bt. So that's 1 plus 6t. And z is z naught plus ct. Z naught is 0, so this is just 3t. And that's it. Okay, and one more. Find the plane containing both the point and the line. So recall, for a plane, we need two things. We need a point on the plane. We've got that. That's given, P. And we need a normal to the plane. So a good way to get the normal would be to find 3 points in the plane. So I've got my P. I can get a Q, and I can get an R from the line. So in my solution start, I've got my P. To get Q, I set t equal to 0 in this equation for the line. And if I set t equal to 1, then I get R. So there's my 3 points. And again, I can just take their cross product as the normal to the plane. So let's write down PQ and PR. PQ, I take the Q's minus the P's, and I'm going to get negative 4, 3, 0. And for PR, I take the R's minus the P's. That's going to be 3, 1, 5. And PQ cross PR will be my normal. And that's I, J, K, negative 4, 3, 0, 3, 1, 5. You should pause and see if you can do that cross. You should get 15, positive 20, negative 13. Okay, so now we've got a point. Remember, my P is x naught, y naught, z naught, and that's my negative 1, negative 2, 4. Got a point and a normal, and I can do the use me every day. So I get 15 times x plus 1 plus 20 times y plus 2 minus 13 z minus 4 equals 0. And you can check my arithmetic on this, but I believe we're going to get 15x, 20y minus 13z equals negative 107. And that's it. And that's the end.